integrals with absolute values. Look at this example. The area from 0 to 3 of the absolute value of, let's say, x2 minus 3x plus 2 dx. Okay, so how do we do this? We have an absolute value. So very simple. We need to understand the sign of what's inside the absolute value. Okay, so let's go and let's analyze with Z, I think. The sign of x2 minus 3x plus 2. Okay, so first I'm going to see when does it become 0. So x2 minus 3x plus 2 is equal to 0 if and only if. So I'm going to factor x minus 2, x minus 1 is equal to 0 if and only if x is 1 or x is 2. Okay, so this is when the what's inside the absolute value becomes 0. So at this point, I like to do a sign table as follows. X, like this, and it becomes 0 at 1, and it becomes 0 at 2. Okay, and here I will have x2 minus 3x plus 2. Okay, so you understand what I'm doing, right? We've done this in Calculus 1. You've done it.
Sure.
Yes?
Did you write x2 that's cut off on the side?
Okay, it's x2, yeah. I'm going to move it. It's pretty tight here.
So it's just like using the critical points to find intervals.
Exactly.
Okay.
Exactly. Okay, so x2 minus 3x plus 2 becomes 0 at 0 and 2, at 1 and 2, sorry. And then I must decide if it's positive or negative. So if you plug in any value here that's before 1, for example, if you plug in x equals 0, you will get a positive, you'll get 2. If you plug in a number between 1 and 2, you should get a negative. And if you plug in something more than 2 here, you will get a positive. Is that okay? So the absolute value of x2 minus 3x plus 2, this is really small, sorry. I'll just go like this. That's better. Okay, perfect. Okay. So the absolute value, if x is less than 1, then what's inside is positive. So I could just take out the absolute value. The absolute value is useless here since it's already positive. So from anything before 1, this function, this absolute value function, is just what's inside. I could get rid of the absolute value. Do you understand this? Okay, because the absolute value turns this into a positive number, but it's already positive, so I could just rewrite it. However, between 1 and 2, what's inside is negative, and so how do I turn it into a positive? What do I do?
The negative outside.
Very good. So I put negative, that's x2 minus 3x plus 2. And if x is greater than 2 or equal, it's positive, so it just stays x2 minus 3x plus 2. Nothing, I could just take out the absolute value. Okay, so this is what I have to do. I have to analyze the sign of what's inside the absolute value, and I'm going to eventually have to do 3 integrals. Okay, so let me set it up. So using what we just discovered here, this integral will be equal to, so I'm going to go from 0 until 1. I'm going to take the positive, x2 minus 3x plus 2 dx, plus from 1 to 2, I will take now the negative. And then from 2 to 3, again, positive, x2 minus 3x plus 2 dx. And that's it. I have 3 easy integrals to calculate and add them, and I'll be done. Did you understand the process? Okay, let's do it. Let's finish it off. So this is x cubed over 3 minus 3x2 over 2 plus 2x from 0 to 1. Then minus x3 over 3 minus 3x2 over 2 plus 2x from 1 to 2, and plus x3 over 3 minus 3x2 over 2 plus 2x from 2 to 3. Equals 11 over 6. Okay, so a quick applications to physics. So if v of t is the velocity of an object or whatever at time t, okay, then, so this, you've probably done this in mechanics. It's displacement over interval t in AB is, so D, so it's actually a vector, okay? The integral from a to b of v of t dt. Okay, so we're just in one dimension here. There's only one variable, which is time, okay? And the answer to this could be either positive or negative. So if it's positive, it's a positive displacement. If it's negative, it's a negative displacement. That's why I put an arrow, because it's a vector. Okay, and this could be seen in physics. You probably learned this, that if this is the velocity time graph, and let's say it's something like this, velocity is like this. So from A to B, you would find, if you remember, the area here. Okay, and the area would give you the exact displacement from time A to time B. Clear? But its distance traveled, okay, again over interval t is in AB, is, so the distance, now this is not a vector anymore, is the integral from A to B, and now you have to take the absolute value of the velocity. Okay, so again, okay, so here you would add this area and you would minus this area, but here you would add this area and you would add this area. Okay, so what you need to remember is this. The displacement is the antiderivative, right? The integral, the definite integral from A to B of the velocity. And the distance is same thing, but you have to take the absolute value of the velocity. And that will give you the distance traveled. Okay, let's try an example. So let v of t is negative t2 plus 4t minus 3. Find the displacement and distance traveled on t between -1 and 6. Okay, that's correct. So first one, let's find the displacement. Oh, can't see. so the displacement is the integral from -1 to 6 of v of t, which is -t2 plus 4t plus 3 dt. And that's pretty easy. Just find the antiderivative. So -t cubed over 3 plus 2t squared plus 3t evaluated from -1 to 6. Did you find? Do you have an answer for me?
I found minus 70 over 3.
Okay, anybody got this as well?
I got the same.
The same? Okay, so let's trust you. -70 over 3. Okay, it's negative, doesn't bother us. Okay, a displacement can be negative. That's why I put a vector sign. Negative means in the opposite direction. So probably along the negative direction of the x-axis, for example, or from the t-axis. Okay, the x-axis, I mean. So d is the distance now. We have to take the absolute value of -t2 plus 4t plus 3 dt. So let's analyze the sign. So -t2 plus 4t plus 3, 1 is that equal to 0? Divide everything by -1. No, sorry. Oh, I wrote it wrong. It was -3. But anyways, you gave me the right answer, so I'm assuming you didn't make the mistake. Okay, so it's minus a plus. T minus 3 times t minus 1 is equal to 0. So t is equal to 1 or t is equal to 3. This is when it becomes a 0. And so I do my sign, not x, but t. -t2 plus 4t minus 3, and then the absolute value of -t2 plus 4t minus 3 at 1 and at 3. That's when it becomes 0. Okay, and then I plug in something less than 1. So for example, if I plug in 0 here, I'm going to get negative, positive, negative. And if what's inside is negative, when I take out the absolute value, the sign changes. So negative t2 plus 4t minus 3, and here negative t2 plus 4t minus 3, and negative t2 plus 4t minus 3. Okay, so what does my integral become? So I start at -1. So from -1 until 1, it's this function here, which is t2 minus 4t plus 3. Okay, so I change the sign right away inside. Plus this one here, which is so from 1 until 3, negative t2 plus 4t minus 3 dt, and then plus from 3 until 6 of this here, which is t2 minus 4t plus 3 dt. And that's what I have to calculate. Does anybody have an answer for me for this?
The final answer is 24.
Did anybody else get 24? Before I read it?
I got 26.
26.
I got 26 also.
26 as well?
Yeah.
So it's 26. That's it.
Sure. For the part, for the table part, can you explain how the last value is negative?
This here,
Yeah, because
this,
minus 4 squared is 16. Or
right?
do you put the minus outside?
Yeah, the minus is outside. So minus 16
Oh, okay, okay,
plus 16 is 0, minus 3 is negative.
okay.
So even and odd functions. Okay, so a function f is even if f of negative x is the same thing as f of x. Okay, so what does this look like? It's perfectly symmetrical with respect to the y-axis. So this is an even function. Okay, so if you do x or if you do minus x, you will have the same y. Okay? F of minus x and f of x are the same. Good?
So like parabolas and stuff?
Exactly. Parabolas, very good example. So for example, y equals, well, not every parabola, but the parabolas that are centered on the y-axis. For example, y equals x2, it's an even function. True, because it's symmetrical with respect to the y. Okay, and if you check f of minus x, you could see right away. I'm just going to write f of x here. Okay, if you see here, f of negative x is equal to, so negative x squared, right? Which is equal to, you know, the negative when squared it cancels, so it's x squared, and that is equal to f of x. So you see negative f of negative x is exactly equal to f of x. Okay, so this is symmetrical with respect to y-axis. So what's interesting about that? Well, why do we mention this? Because the area now from negative a to a of f of x dx. Okay, so if I want to find the area from negative a until a, well, I just need to find the area from 0 to a and double it. This is equal to the area from 0 to a, 2 times that. Make sense? This is the same, it's symmetry. So instead of doing from negative a to a, you could just do from 0 to a and times 2. Questions? So that's the main advantage of dealing with an even function. It's not such a big advantage as with the odd function, as you will see. With the odd function, the advantage is much better, but big. A function f is odd if f of negative x is equal to negative f of x. Okay, so if I were to represent this graphically, it will look something like this. I don't know, let's say that's odd. Okay, so f of negative x is exactly the negative of f of x. Okay, so if this was negative 2, well, f of x will be 2 minus whatever you have here. Okay, and the graph is symmetrical with respect to the origin.
Wouldn't that make the displacement 0?
Yeah, the displacement, exactly. The displacement in this case, from negative a, if you were from negative a to a, yeah, you're right, the integral would be 0, and that's the whole advantage of an odd function. Okay, so let me give you an example of an odd function. Can you give me one?
Yes, please.
What did you say?
Yes, please.
I wanted you to give me one. Okay, so x cubed is an odd function. Okay, because if you do f of negative x will be negative x cubed. This would be negative, right? It's an odd exponent, so it would be negative x cubed, and that would be negative f of x. See, f of minus x equals minus f of x.
So can we say that when there's an odd exponent, it's an odd function?
Pretty much.
Okay.
Okay, but there is also another, let me give you another example here. F of x equals sine x. Sine x is also an odd function. Because, as you probably know, well, this looks, the graph I just drew here pretty much looks like a sine function. Okay, and I think that you know that sine of negative x is equal to negative sine x. Okay, as opposed to the cosine, and the cosine is even because cos of minus x is cos x. Okay, and the big advantage of this is that the integral from negative a to a of f of x dx will be 0. That is very good for us. Okay, so on the test or on the exam, if you see a definite integral that goes from negative 5 to 5, negative 10 to 10, negative pi to pi, if you have the same negative a to a, ask yourself, are you dealing with an odd function here? If it's an odd function, you don't need to do any calculation, you just put a 0. Okay, you just write 0 and you say, since this is an odd function, and of course you have to show that it's an odd function. But it's much easier to do that than to evaluate the integral. Okay, sometimes.
Wait, so we can do this before doing the integral?
Yeah. And
Okay.
make you avoid doing the integral. I'll give you an example right now.
Okay.
Example. The integral from negative 1 until 1 of tangent to the power of 5 of x times square root 1 plus x2 over 8x10 dx. Okay, so I think there is no way that you could evaluate this integral. I have no idea how I would even proceed to evaluate this. I don't know if it's doable, okay, with analytical methods, okay, or other than numerical methods. But I do see that I have from -1 to 1. So I hope, I pray that this is an odd function, or else there's nothing I can do. So let's see if it's odd. Okay, so is f of x equals tan 5x times root 1 plus x2 over 8x10 an odd function? That's what I ask myself. So let's see. Let's find what f of minus x is. So f of minus x is tangent to the 5 of negative x times square root of 1 plus negative x squared over 8 times negative x to the power of 10. Okay, you know that tangent is an odd function, you know that? Because tangent is sine over cos. Okay, I'll do it. I'll write it for you. So sine power 5 of negative x over cos power 5 of negative x times square root of 1 plus, well, negative x squared is just x2, and 8 negative x power 10 is just x10. Okay, and that's equal to, so we said that sine of minus x is minus sine x, to the 5 stays minus. So negative sine 5x over, and cos 5 negative x is just cos 5x, times square root 1 plus x2 over 8x10. And that's equal to negative tangent 5x times the root 1 plus x2 over 8x10. And that's exactly equal to negative f of x. Okay, so f of minus x is equal to negative f of x. So it is odd. Okay, and so my integral from -1 to 1 of tangent 5x square root 1 plus x2 over 8x10 dx is equal to what? Zero.
So this is the proof we're gonna be expected to write.
Excuse me?
This is the proof we're gonna be expected to write if it's an odd function.
Yeah,
right?
this is how I have to show me all these steps here to show me that it's odd. And that allows you to say that it's zero. Exactly.
Okay.